Okay, thanks very much for coming. This is Pwning the CI. My name's Steve Giguere. Let me give you some background as to why this talk even exists. About last April, and remember the timeline? Last April, this happened. This is a real attack. I'm using gigantic air quotes if I can there. Updating our build YAML on GitHub. I didn't used to do this, but I'm gonna point out this little, that's really small. But this says myoung34. All right, this is a new, if you've seen the presentation before, I know one of you has. I didn't do this before. That's because there's been a development. What he suggested we do with our build YAML was change the entire thing, slightly unsubtle, to just run a PS and an env, and obviously have that go to the log. The important thing about this slide is that it's a self-hosted runner, and we thought, all right, how bad could this have been? That was really all we thought. My manager said, Steve, explore how bad this could have been. Do a talk, maybe change our product checkoff, open source, and see if it'll help. So that's kind of where we are. Now, running self-hosted runners on a public repo is bad. Everyone does it though, according to a cheat sheet by GitGuardian, which has a lot of good stuff like this. Only run workflows in trusted code, harden your actions, don't use self-hosted runners on public repositories. So I immediately checked to see how many hits I would get on self-hosted runners in public repositories. It seems nobody's listening, which does explain how somebody was out there with an automation trying to find things like this. So how far could I go? Well, all right, I didn't introduce myself yet. That's me. That's a perfectly safe QR code. I'm in security, you can trust it. I've worked at a bunch of companies talking about security. My specializations are more supply chain related now. That's very buzzy, so that's why I said that. Kubernetes, containers, all that kind of stuff. I do also run a meetup that takes place in London, if you happen to be in London, called DevSecOps London Gathering. I also have a Friday Twitch show around 3 o'clock where I summarize all things that happen that are ridiculous in cybersecurity. It's called C9K. It used to be called something quite profane. We had to shorten it for family reasons. All right, GitHub Actions. I can't see anyone, so I assume you've got your hands up. You know what GitHub Actions are, GitLab Actions. They're actually really similar, GitHub and GitLab, we found out. So a lot of what I'm saying works on both. An event happens, you've got a runner, it could be yours, it could be GitHub's. Stuff happens. What could go wrong? I like GitHub's documentation. I really found it inspiring, and to an extent, it tells you that GitHub workflows are defined in a certain directory, and it makes suggestions of what you could do with them, which is great. One workflow to build and test, one workflow to deploy your application, one workflow to add a label. And I added sanitization of issue titles, just something that might be helpful in case you have certain internal formats for this kind of stuff. That all seems legit. Now the big problem we found with this is that GitHub can and will run new workflows that are committed to that path, even if those are the committed files. Like it doesn't really know. It just, if you commit one, it will then try and run it, even though it's not vetted it yet. Sounds bad, right? You'll see. Metadata that's available to workflows, issue name, issue description, there's a big list. They are used a lot by workflows in ways that are not great. We would call that in the AppSec world unsanitized inputs. But because they're being used in an ops world, most people don't realize that's actually really bad. The workflow directory, which is very special, it's like running code on code. It has the same access controls as the entire repo, so there's nothing really special about it, ideally right out of the box. All of this put together can go quite wrong. So we started thinking about it and thought, well, what could we do with all these things? If no one's sanitizing the issue title, what can I do with the issue title to make things happen for me? If there's a workflow to build and test my pull requests, well, what kind of power does it have? GitHub issues it a token, and sometimes people create personal access tokens or maybe store secrets in there to do things. What if I can get access to those? And then the last one, which is a little bit more AWS-ish, because we use AWS and we use GitHub, is we put things into AWS via GitHub Actions. What power does this have? Do we put AWS keys in there as secrets? Not anymore. So the kind of attacker's guide to this, and this is going to get interesting later when I show a real world example of this, where I'm going to do it, but I'm going to talk about somebody else who did it as well. If you've never, this is what this person did. If you're an external attacker and you submit a new PR and you've never contributed before, The only thing that makes that workflow not run is that little button up there that says approve and run. Now, we didn't push that button, hence our build didn't put everything into our log. But what's interesting is the text above, you can't see that text. You have to click on the learn more, which is grayed out, to get to that help that shows you, it tells you, ooh, be alert if someone actually commits something to the GitHub workflows directory, because there could be bad stuff in there. What's also interesting is if you have no workflows whatsoever, the text from GitHub says this: well, why don't you have any workflows? Surely you can use workflows to catch bugs and do security. So you're kind of taught that you always want the workflows to run. So when you see an outside contributor, and you like shiny push buttons as well, because we're humans, you've already been trained to push the button, and it might run. Now let's say, for example, I'm assuming that no one's going to push that button. My next job, it sounds like I'm a bad person, is to become a malicious insider. And the default to make that button not come up on every public repo, if you haven't gone and specifically changed it, is that the button only comes up for first-time contributors. All right, so how do I become a first-time contributor? Change the README? Ace. It's pretty straightforward. You can become a force for good, a positive contributor, really easy to an open source repo. So let's talk about the first example, issue grooming. I went and did some looking around GitHub to find what are people doing with this metadata. I found this one, which I was a little like, oh, awesome. Somebody's creating a blog post and putting metadata onto it, creating the title, using the issue description. And I thought, well, what if I were to just make the title some kind of actionable HTML, and would it just pop up and ask you for your login and password for GitHub if it was hosted on GitHub? Hypothetically, might. Or perhaps worse, this person's innocently echoing the issue title and description to a log just for logging purposes. Logging is good, observability is good, all of these things are really good. But there's kind of a problem with that. Now, the one I decided to play with is this one. This is my force for good. This is my first-time contributor scenario. I'm going to add some sanitization of the issue title to make sure no one's doing something weird with it, and it's conforming to a nice, tidy issue title format. So I'm going to contribute this. Now, before I get kind of crazy on this, let me just make sure I'm going to lose track where everything is. Those are my notes. There's 2 characters in this. This is all live. Here's the baddie. This is Loud Canadian. You can see him up there. It looks surprisingly like me. And this person's about to commit exactly what I just showed you to a repo, which is cool. I've kind of set this up beforehand. I'm going to create the pull request, and it's going to go. All right. Now we come over here. This is, hey, look at that, a pull request. And there's my approve and run. Awesome. Now, I've already checked. It is a workflow, but it triggers on issues. It's not going to run. Now, I do have a generic workflow in place that I'm aware of, so I'm just going to say approve and run. It's going to check things out. It's going to be happy with it. And you can see this is my generic one, CI build. It doesn't do anything. It's just there for show. You get it. And it's going to wait and run this check. Now, this is the idea. And while this is running, I'm going to show you a few other pieces to this puzzle. Over here, I have this thing called webhook.site. Anybody ever see this before? It's a lot of fun for playing with APIs. Every time you go here, let me just make sure I'm not going to destroy my AC3 destination and make sure it's actually functional, because it's sitting there waiting at the moment. Bro. So it's just waiting for contact. And then over here, I can merge this, confirm merge. Fabulous. Now it's all part of the scene. There's this guy over here. Hands up if you recognize what this is doing. Just like anybody in their hack said, I got a hesitant. All right, this is a netcat. It's waiting. This is what you do if you're going to create a reverse shell so you can get access to something remote by not actually trying to ask for access, by getting in by some kind of remote code execution and returning access to me. Just a little bit of foreshadowing. So, this is all looking pretty good. Let's pretend you never saw that. You can see I'm on the code here. And in my workflows directory, issue tech is there. Super duper. So what if I go to issues and I create a new issue? What would the title be? This is why I have notes. And I hope these are like so impossibly small. This is why I'm wearing glasses. Well, I should be. And I'm going to create an issue called this. That's a good issue title. Boring. Don't like your project. Cool. Now over here, in my actions, look, it's going to run that. Still running it. Now what it's probably going to do over here, though, provided I don't screw it up, which does happen, by the way. I one time forgot to put the last backtick in, and it didn't do what I wanted it to do. Or I pasted the wrong thing one time. Oh, darn. It was going so well. What did I do? It looks correct. Where are my glasses? This is what happens when you don't wear your glasses. The idea was it should send it out to there. Why did it not do that? Whew, delayed reaction. We're all cool. All right, great. So it did what I wanted it to do, and it actually sent all the environment variables from that runner to my waiting system, my very slow to react waiting system, which is bad because if I have access to certain environment variables, sometimes you pull things in and you store certain keys, certain Postgres database things, and you store them as environment variables. It really was not hard at all for me to get access to all the environment variables for that GitHub runner. So that is kind of lesson one about sanitization. This is essentially what I did. Because I put it in a backtick, everything that's in a run is running in a bash shell. And if it's in a bash shell, then if you backtick it, even if it's in quotes, even if I'm just doing equals, it's going to resolve the contents and it's going to execute the contents. And if I exfiltrate something to where I want it to be, it's not ideal. So we already did that. So there's certain things you can do in place. So this really only applies to existing workflows, because if I'm sending in attacking workflows, it doesn't work. But there are environmental protection rules and environmental secrets that you can put in place to make sure workflows don't have access to everything. And certainly things like issue grooming, where you're not really doing anything except adding labels. You should make sure that you have the environment protection rules in place. And by the way, there's a URL down at the bottom. The last slide has every URL I reference. So if you're ever going to think, okay, well, what did he talk about? You can take a photo of that or ask me for the slides or get them from the event. And it's as easy as putting a little bit of environment in there. So it's really all this kind of stuff is very preventable. It's just very few people actually do it. Some extra things that would be good, and just general things, is if you're going to add any sort of access to your cloud, make sure you have short-lived tokens. If you're using self-hosted runners, which you normally are, make sure that you're creating role limit conditions to limit the source IP so that even if I get a token out of your self-hosted runner, I can't use it because I'm not in the right space. The advantage of self-hosted runners is that you can know what the IP address is. So if something does escape, make sure you take into account that that's actually a security issue, not a security risk. Utilize AWS access reports to make the role policy least privilege, and use OpenID Connect. There's a guy named Paul Schwarzenberger going around at the moment doing a how to use OpenID Connect talk. If you can catch it, you can see it on YouTube, definitely do that. The docs are just below, and again, they'll be online. It means you never have to store IAM information in your GitHub, because secrets, by the end of this, you're not going to store anything as secrets, I would imagine. That's kind of one of the takeaways. All right, auto-approving your own pull request. This is a little handy tip. So branch protection rules are good. You should almost have everything, you should have them turned on in GitHub. B, you should almost always have everything ticked, and it's really hard to do that, but you should. This is just a basic branch protection screenshot turned on. I'm going to do this in a second. I'm going to turn on my branch protection. You might think, all right, no, I don't want people committing directly to main. I want a pull request before merging. I want that to be a necessity. Automatically require approvals is there, and you think I did it. Now, unfortunately, the default for require approvals is just 1. And it's a little sneaky down there, because if we go back to the good guy, there we go, and I go to my settings, and I'm going to turn on branch protection now, branches. This is obviously a brand new thing. Main, I'm going to require. Cool. Now, it's a little small, but I mean, it should be 2, or 3, or 4, or 5. But the default being 1 is kind of like, I'm running out of time, I'm just going to put 1. You really should have a lot of these things. We're going to talk about require signed commits a little bit later and why that's important. I love this. Do not allow bypassing of all these settings. What? Why is that tick box even there? I never tick these bottom ones. So we're going to just create that. Oh, this happens to everything. I always forget. I always say, remember to have your two-factor open before you start the talk, Steve, because I'm using two-factor authentication. There's a little lesson for everybody. Two-factor authentication is your friend, but it also disrupts your talk. If I don't put this in there, then it makes the further things way too easy. And if I'm going quickly, it's because this talk can technically go an hour, because there's a lot of stuff you can break. All right, amazing. And the last thing I'm going to do, because I was such a good person, Loud Canadian is my favorite and only contributor. I'm going to add Loud Canadian to the repository, because I trust them because of that amazing work that they've done for me up to this point. So now I'm going to come back here. I'm going to go to code. And I'm going to see I have invitation. Oh, thank you. I would like to be a contributor on your. Okay, so now I'm part of the team. And that changes a lot of things. I'm going to mention one other thing about what can workflows do. Now, we talked about approving your own pull request. The default settings for any workflow as soon as you create a new repository, the default settings are not what I have up here. These are the settings you should have. Read-only repository contents for the GitHub token within your repository. It's generally 99.999%. That's all you need. What you do not need is the default settings. Read and write permissions on everything. And this crazy one down below, allow GitHub Actions to create and approve pull requests. Well, really? Why? This wasn't really there before. This changed this year, the ability to say read-only and restrict the GitHub token. And in fact, the line above where it says choose whether GitHub Actions it's reiterating, that only showed up a few weeks ago. When I first started doing this talk, I had to redo these screen captures because people weren't doing it. And they're like, no, really, you don't want this. The difference between the two, this is if you do what I said you should do, and this is what happens if you are otherwise. This is what a GitHub token can do. It's a lot, isn't it? There's one thing it can't do, and that is you can't merge your own pull requests. That would be an insane capability, wouldn't it? We'll talk about that later. All right, GitHub tokens. How long do they last? This is really all I want you to take away from this, and that is up to a maximum of 24 hours, expires when the job finishes. So if I do have an overprivileged GitHub token, it only lasts 24 hours. What can you do in 24 hours? A job can only be, in a workflow, can only be 6 hours. So really, it's only 6 hours. Okay, that's just food for thought for later. So if now I know my workflow is going to run. I know it's going to run, and there's branch protection on it. What if I want to submit something, but I want to bypass the approval process so that whoever is maintaining this project sees a pre-approval and goes, oh, it must be fine. Merge. Well, that's how you do it. And I realize it might be small, but I'm not drawing in any information there. It says curl pull GitHub API. I'm using metadata I'm provided, GitHub repository. I'm using the GitHub event number, which is the pull number. I'm using the GitHub token because I'm a collaborator. And this will work. This will approve my pull request. Cool, right? There are ways to get around this using things like code owners to make sure only certain people can approve. So even if you auto-approve, it doesn't count. That'll be something we'll learn later. Attack number 3. And this is where I'm going to kind of bring everything together. There's one little real story that I'm not going to play out, but how are automations with more privileges created? This is straight out of GitHub again. This is their documentation. If you need a token and the permissions aren't available, well, create your own personal access token that has those permissions. This is how you do it. Go here, and then save it as a secret. Right out of the documentation. Sound advice. Keep that in mind. Oops. What could I do? What if somebody did that? This is just a little hypothetical aside. So what I did after reading that is I just started looking for anybody who might encourage this behavior. And I found more than I should have things that are trying to tell you create a personal access token. And one of them was auto-merge pull requests. And I'm like, okay, I know that capability is not available. I found many actions that, if you want to do this, show you to create a token that does it. So then I started looking for, well, who uses this action? Maybe nobody uses it. I was so wrong. There is a whole bunch of NPM modules that are using this auto pull request. I thought, okay. So now I know there's a personal access token there, which means I already know how to auto-approve, and I know I have a token that can auto-merge. So now I can become a part of this project, and I can just add whatever code I want, and then everybody downstream has my code. Yes. Anyway, but I digress. I'm going to submit this one. I'm going to zoom in on this little bottom bit if you want to see kind of the nasty stuff. So I've got that environment variable one in there, right? But I've added a little one above it because secrets aren't environment variables. They're kind of stored in this kind of, the ether as you go through the workflow. So they're not really available, but they are available, particularly if you echo them to a file, and then they become real in the shell, and then I can curl that file out to my destination. So you can get all the secrets, and you can get all the environment variables. And I would really like to keep this running for as long as I can, so I have the GitHub token, or whatever other secrets are there, to do whatever I want. Because I'm a jerk, I'm going to do something worse than that. So if you know what that is, the important bits are the little bit that says sh followed by nc. This is using the same command. I'm running a shell within a shell, and I'm going to push it out to my destination. OK, let's see if this works as slow as it did last time. Hopefully not. Hopefully it'll be much quicker. So here's my baddie, my goodie, my force for good. I'm going to create a new file. It's in my GitHub workflows directory. I'm going to call it pwned.yaml. Don't ever call your malicious stuff pwn. It's a bit of a giveaway. Another little hacking tip there. You have that for free. So I've got this notes. By the way, any of this stuff, if you want it, you can have it. It's all for the greater good. Here's one I wrote earlier. All right, so this is it. Now, I realize this is small again, but you can see that I've actually got the approve in there as well. Just because, kind of showing off, I suppose. And look, I've got branch protection, so I can't just push it back in. So that's good. Protected branch. I'm safe. And I'm going to call this innocent workflow. I think that's what I want to call it. Let's propose that new file. Create, I don't know. Sounds good. Create Pwned thing. All right, good. So merging is blocked because it's waiting for the review, which is cool. We can view that over here. It might be easier to see. Light on dark, dark on light. Hey, look, I'm approved. Oh, the GitHub Action Bot approved me. Hurrah! So I'm on my way. But you see now, I was called Big CI 22. But it's running because I've already got past the I'm a force for good. I did change the README. I did something stupid. Interesting. So I got that over there. And over here, I had to refresh this last time, and it was because it was being silly, wasn't it? Now I've got my GitHub token, my pat, I've got my kubeconfig, got my AWS secret, and I've got my AWS key. Cool. I'll figure out what I could do with those later. So now I'm back over here. And who am I? All right, I'm runner, and I'm on the runner. What's cool about that is it also means that the GitHub token stays alive, so does anything else that might be ephemeral and was going to be killed after the workflow ended. This is all very bad. There's kind of a bonus section to this, where I did originally stop here, and then I got greedy, I guess. You probably can't read that, which is good. It makes the magic happen. So I'm just going to run that. I'm going to rush back here. All right. Oh, do you see it go from open to closed? That's cool, right? I'm still on the runner. Yep. And if I go to my pull requests here, now say I got here late. What pull request? There's no pull request there. I'm just sitting on the runner. And say I'm thinking, well, it still seems weird. Who's doing this stuff in here? What's this? What's he doing there? How odd is that? By the way, signed commits. You should make sure you know who's actually contributing to your. So if files change 5, that's really strange. I go in there and nope, that doesn't work anymore. So a little bit of funny business has happened there to cover my tracks and yet still keep me on the runner. So now, do I have access? Normally, they kill the workflow for me, thus rendering everything dead, yet I'm still here. So now I'm kind of permanently resident provided something weird doesn't happen. I don't stop the self-hosted runner. It's really easy to make this stuff happen. This is why this is the cautionary tale. Now, the result, a persistent reverse shell on a potentially self-hosted runner, and I've covered my tracks. Quite cool. What would I do now? Lots. I would look for cloud secrets. I'd change the logging level on the runner in case it's a shared self-hosted runner and start looking at things that were happening and maybe look for the location of other code that might be being built there. I'd certainly grab the GitHub token and look for the processes, the network capability. I'd run an nmap. I'd check for access to storage, like S3 buckets. I'd certainly look to see if the runner had access to the ECR image repository without immutable tags, which means I could start changing contents of the ECR registry and building my own things in from there. Cool. Are the runners on a VPC? It's internal. Why would it be? Change the IAM access. Is the actual runner itself in a container or is it not in a container? I can get out of the container. That's not a problem. What roles and access does the internal VM actually have? Usually more than it should. Or I could elevate privilege then to root and really start going to town, right? That would be really fun. You might be thinking, come on, Steve, you're getting far-fetched here. I'm just going to do two little things at the end, and then I'm going to give a little sort of advice. By the way, I did that little Python thing because certain things don't work unless you're in a better shell. If you've seen this command before, it's the greatest and worst command ever. It's probably pretty low. I'll push it up in a moment. It's a Docker command. So if you can see who I am now, or I can just really drive it home. So now I'm root on the GitHub runner. Now, I can't do anything. GitHub runners are amazing. They're very well sandboxed. But if I was on a self-hosted runner, this would be super bad. And most self-hosted runners have Docker on it by default. Amazingly, the GitHub and GitLab ones do as well. And you can use Docker to just go straight into root. So that's all bad stuff. All right, let's get back to our show. Whoa, where did my presentation go? Ah, where'd it go? Did I close it? Thankfully, I can just go get it back, but things I've learned in supply chain. All right, bear with me while I figure out where on earth I was, because it just closed itself. Nobody's recording this, right? All right. There we are. Okay, this is my cautionary moment. You have this information. It works. The important thing is don't be a Biff about it, all right? There's a certain thing. This is where, if you've seen this talk before, something happened in the last 2 weeks. This article came out. Do you remember the name that was at the top of our thing back in April? It was myoung34. So I was doing one of my Friday shows, and this came up on my radar, and I was like, this is interesting. This sounds exactly like what I'm doing. And I thought, Zucker Punch, he ran Facebook? So I looked at the timeline, started off in April. And there's detail down below that says he just went nuts, and we were one of the potential victims of this. His attack on us was really quite remedial. Obviously, it got better. And eventually, PyTorch became a victim. Now, not Meta, not Facebook, not Mark Zuckerberg, PyTorch, because PyTorch was a Meta project. They've since given it to the Linux Foundation, maybe because of this. But he goes through. Now, the thing I don't like about it, and this is in my humble opinion, is that it was an effort to get bounty straight out of the box, which means he was obviously trying to get bounty from us. But he was only attacking open source projects. I love bug bounties. By the way, let's do this. I love bug bounties. They make the world a safer place. Bug bounties on open source projects are not cool because if he basically got money out of PyTorch, PyTorch is an awesome deep learning platform, and AWS uses it, Tesla, everybody uses it. It's freaking amazing. It's a gift. Don't screw with it. Anyway, personal opinions. But he did make some great observations. Some of the things I had on my list, his self-hosted runners that he saw did have access to S3 buckets. They did have access to ECR. They were not in a VPC. So the thing I didn't do that was go and do the actual research, as much as I don't agree with his methods, did kind of conclude that this happened. So that my message to you, if you're using self-hosted runner on GitHub and deploying to AWS, be very careful. best practices in this space. How am I doing? Great. Be super careful like when you're adding contributors, because we were an open source project, Chekhov, early on, and we were just bringing in contributors like crazy because we wanted anybody to help us make the project, right? And it wasn't until we had like 1,000 stars and we had a company around it, we were like, who are these people? We just wanted them in. We should turn on branch protection. Yeah, that's a good idea. It really happened late. And there's a lot of stuff out there that's like this. Hey, PyTorch. PyTorch didn't have a lot of these measures in place. Always have branch protection. Always have more than one reviewer. Do not run workflows unless you're 100% sure. You really should change that run workflows to anyone who's an outside contributor. Anyone, not just a first-time outside contributor. If they're not a collaborator, never ever let those work. Make sure you vet that. Environmental protection is there. Ephemeral GitHub tokens, or if you have to use tokens, make sure they're extremely short lifespan and the lifespan is not controlled by the workflow. And make sure it's least privilege. OpenID Connect I've already mentioned. GitHub logs. The code owners file I'll talk about in a moment. And the signed commits, of course, because you don't want random outsiders looking like they're. What's interesting about, you think probably, I don't know if you know how I did this. You just set your git config to a user. But if it's a real user, even though you can't get their email address, GitHub just props up, shows you the profile photo. Isn't that awesome? You just had to go at his email address and boom, there's his face. Awesome. Thank you. So the code owners file, code owners is the easiest thing ever. You just put a file in the directory called code owners, put the approver in, and that's it. That's the person who has to approve anything that's been submitted to there. There should always be a code owners file in your .github workflows directory, always, because you probably want a maintainer. It's the only thing that kind of separates that path from the rest of the world. So it's a really good piece of advice. Open source tools that can help you. There's not a lot out there at the moment that's looking directly at CI. I like the OpenSSF as an organization generally. They have something called Scorecard that will, if you give it a GitHub token that you've kept to yourself, and then run it on your command line, it will then check to see if you've got branch protection with the right settings. It does have a thing that says check for contributors from 2 different organizations, which kind of goes against what I just said, but it is a good thing, like if you're managing it. Avoid dangerous coding patterns. It does have a very clever, I ran it on some of the weird things I did, and it caught some of them, but not all of them. So it's definitely a good thing to do. GitHub workflow tokens should always be read-only. It's not the default. If you have open source repositories, go do it immediately after this, because you don't need the default setting at all. The last one, this is a little self-promotional. Chekhov is an open source project. This is where I spend most of my time, and a lot of the things that I did fed directly into this. So now we have new rules that look for patterns that look like reverse shell, that look like anything that looks like it's using metadata in a run in a way that could be then exploited. We're looking for that. So if you want to just check workflows, the combination of OpenSSF to check the repo itself and Chekhov to check the workflow itself is a really good way to make sure that you kind of got some basics in place. Just to see if I think I ran it just before I got here. The output from Chekhov. This is an example output of Chekhov. You can see how some of the examples of things I've got. Like I'm looking for curl. Down there it failed because you can see I'm doing the echo of a GitHub event issue title. So it's looking for things like that just to make sure. It's interesting. Some people ask, well, can I have this as a workflow, as an action? The problem is workflows run in parallel. So the workflow could already been run by the time you actually check it. So there has to be almost like a pre-commit check at running things like this to make sure before workflows arrive. So chicken or egg, yet another problem with workflows. And I'm going to get to the end. All right. That is the end. And before I stop, we're changing our branding, and we have a lot of t-shirts that are for free. So if you just want t-shirts, the medium and larges and stickers, I brought them along. It's like guerrilla marketing. Sorry, Joe and Phil. And if you're at reInvent in November, I'm doing a capture the flag there in the AWS Jam, where you hack a website and then you break a container and then you get access to the host, and it shows you how to do that and then how to prevent it. So if you're there, come find me. It'll be a lot of fun. That's it. Thanks.
Amazing talk there. We've got Joel coming up next in a few minutes. We've got a few minutes of questions. Joel's talk is actually on building GitHub actions in CI actions. So I expect he's probably somewhere just adding a few notes to the slides. We'll catch up with him in a second. We've got a few questions. Any questions? Yep, over here.
Yeah, do we know? Loud. Do we know if these have been exploited in the wild much? So is there much evidence that people's exploiting this? Sorry, it's me, Trax. Is there much evidence that people are exploiting this in the wild? So it's something that's quite widespread.
Well, so there was the example I put up there, which was the guy, well, I don't want to say his name, but he was the one, he did it on PyTorch. The example of us being somebody trying it on us turned out to be the same guy. So now we're trying to monitor how, I don't know, whether this increases or not, because the team at, well, technically I work for Palo Alto, so the guys at Unit 42 now have started research to work out how prolific is this really, because now that one guy has done it on PyTorch, it's not great because that means other people have seen the instruction set. Mine is cautionary. Mine's like this, you should protect yourself, as opposed to a blog that's a set of instructions. So talk to me in 6 months and when we're done the research and we'll see how bad it is.
Cool.
Okay, we've got time for one more question. Someone had a question? Okay, we got one.
When you were doing your example, you said pwn.yaml was a bad name. What's a good name for a...
Pwn.yaml is a bad name. Yeah, build.yaml. That's a nice, innocent name. Deploy.yaml, something, you know. This is innocent workflow.yaml. These are all good.
Okay,
cool.
Well, thank you very much.
Brilliant. Thank you, everyone.